Assalamualaikum and hi everyone. My name is Cik Rafida binti Rahim.
Hi, my name is Nur Fazana Aina binti Ahmad Zaini.
Hi, my name is Nur Hakim bin Azmi.
And my name is Fatih Nurul Alisa binti Suhaili.
Introducing Chapter 4, Matrices and Systems of Linear Equations. We'll be discussing Subtopic 4.3, Inverse of Matrix, and Subtopic 4.4, System of Linear Equations with 3 variables. Subtopic 4.3, Inverse of Matrix. Our learning outcome is find the inverse of a non-singular matrix using elementary row operation method. Referring to PSPM question 2016, given R is 1, 1, 2, 3, 2, 1 and 3, 1, 4 in a 3 times 3 matrix format. Our first step is to turn R into an augmented matrix form as shown, hence inverse into the form shown in the diagram using elementary row operation method. Then we have to change the non-diagonal entries of the left side of the augmented matrix all to 0. To form the new second row, we use the AD minus BC method, where we cross multiply the row that we change and the row that is unchanged with their coefficients. Then we do the calculation as shown in the diagram, and we repeat the same step for the third row. We repeat the same step for the second column and the third column. Then, next step is changing all the diagonal entries to 1. For the first row, we divide by 8. For the second row, we divide by 8. And for the third row, we divide by -8. Then, we get the final answer of the inverse matrix on the right side.
Okay, next is subtopic 4.4, System of Linear Equations with 3 variables. So the learning outcomes that we can get from this subtopic is write a system of linear equations in the form of ax equals to b. Next, find the unique solution to ax equals to b using Gauss-Jordan elimination method. And lastly, the example of equation and solution for this subtopic. Okay, the first question is write the system of linear equations in the form of a matrix equation ax equals to b. So the first step is we need to do 3 equations like I have stated here. Next, we need to transform these 3 equations into the form of ax equals to b. As you can see here, A is for coefficient matrix, X is for matrix of unknowns, and B is for constant matrix.
The next question is state the price for each unit of stapler, bottle of ink and document file. We will solve this question by using Gauss-Jordan elimination method. First, we need to draw a table to make it easier and to avoid careless mistake. Second, to use Gauss-Jordan elimination method, we need to write the equation ax equal to b in the form of the augmented matrix. Next, use elementary row operations to reduce the augmented matrix to form a reduced augmented matrix. So after we draw a table, we write the equation that we got from the first question in the form of the augmented matrix. We need to make sure that the non-diagonal entries are all zeros and the diagonal entries are ones, which denoted by capital I. So the first step is look at the column 1. We need to change the number in row 2 and row 3 to zeros by using calculations and form row operations. To form a row operations, I'm using AD minus BC method. We do a cross multiply between the row that we want to change, which is row 2, and the row that unchanged, which is row 1, as shown in the table. Then, for calculations, we need to solve R2 minus 3R1 that we get just now to get the new elements for row 2. The same steps goes to row 3. Then we copy the elements that we get from calculations for row 2 and row 3. So we already got the zeros for the first columns. The same steps goes to the next columns until the non-diagonal entries are all zeros. After the non-diagonal entries are all zeros, we need to change the diagonal entries to 1. So for the row 1, 1/8 times row 1, then we get 1 for the diagonal entries and 7 for the elements in the right side, which is the answer that we want. Row 2 seems with row 1, which is 1/8 times row 2. Then we get 1 for the diagonal entries and 5 for the elements in the right side. Lastly, for row 3, 1/-8 times row 3, then we get 1 for the diagonal entries and 12 for the elements in the right side. Then we get the values for x, y, and z, which is x equal to 7, y equal to 5, and z equal to 12. Therefore, the price for each unit of stapler, bottle of ink, and document file are RM7, RM5, and RM12, respectively.
Okay, when we look to the question, we will get the three equation, or we will get the answer of A is 3x plus 2y plus z equals to 170, 4x plus y plus 2z equals to 203, and x plus 2y plus 3z equals to 162. So the first step to answer the next question is we have to turn the linear equation to the matrix form, which is ax equals to b, ax equals to b, and then we can create the augmented matrix. So our goal now is to transform the left hand side to become identity using Gauss-Jordan elimination method. After we get the identity on the left hand side, the right hand side will become the value of x, y, and z. We have to draw 4 columns. The first column will have to be the augmented matrix. The second column is the row operation. The third is AD minus BC, and the fourth will be the calculation column. We do all the calculations like we have already learned in 4.4. So at last we will finally get the identity at the left hand side, and at the right hand side we will get the answer. So x equals to 31, y equals to 25, and z equals to 27. Or we will get the answer. The final answer is the ticket of the Avengers is 31 ringgit. For Enola Holmes, 25 ringgit per tickets, and the Jumanji goes to 27 ringgit per ticket. The last question, determine how much it would cost Rafida to purchase 1 The Avengers, 1 ticket of Enola Holmes, and 2 Jumanji tickets. So we have the answer for this in question B. Okay, the answer of x, y, and z. So we will just substitute. Okay, Rafida put 1x. Okay, x plus y plus 2z equals to, okay, x 31 plus 25 plus 2, substitute z, 27 equals to 110. So Rafida spend 110 ringgit